Advent of Code 2019, Day 8 is called Space Image Format. The elves' spirits are lifted when they realize you have an opportunity to reboot one of their Mars rovers, so they are curious if you would spend brief sojourn on Mars. Oh, I see. Spirits, opportunity, sojourn. I get it. Very funny. When you reach the rover, you discover that it's already in the process of rebooting. It's just waiting for someone to enter the BIOS password. Okay. The elf responsible for the rover takes a picture of the password, your puzzle input, and sends it to you via the digital sending network. I think this is a play on the Deep Space Network, DSN. Unfortunately, the images sent via the digital sending network aren't encoded with any normal encoding. Instead, they're encoded in a special space image format, SIF. None of the elves seem to remember why this is the case. They send you the instructions to decode it. Images are sent as a series of digits that each represent the color of a single pixel. The digits fill in each row of the image left to right, then move downward to the next row, filling the rows top to bottom until every pixel of the image is filled. Each image actually consists of a series of identically sized layers that are filled in this way. So the first digit corresponds to the top left pixel of the first layer, the second digit corresponds to the pixel to the right of the same layer, and so on until the last digit corresponds to the bottom right pixel of the last layer. First digit corresponds to the top left. Second digit corresponds to the pixel to the right of that in the same layer. Okay, so it's just a series of colors that are grouped into layers. Okay. For example, given an image 3 pixels wide and 2 pixels tall, the image data 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2 corresponds to the following image layers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2. Okay. The image you received is 25 pixels wide and 6 pixels tall. To make sure the image wasn't corrupted during transmission, the elves would like you to find the layer that contains the fewest 0 digits. On that layer, what's the number of 1 digits multiplied by the number of 2 digits? Okay, so it sounds like we just split it into chunks. AOC lib creates AOC 2019 source main. Yeah, we split it into chunks, and then each chunk we can count up the number of zeros in there. Zeros, ones, and twos. Right, because that's all we care about, the zeros, ones, and we don't care about any of the other numbers. And then the one that has the fewest zeros. Okay, so this feels like to me a can you read the input format properly? I did that already. Let's go here. Let's go here. $1. Spoof. Reading that lovingly made problem statement, getting me excited for AOC this year. It's always fun. So if you haven't done it before, I highly recommend it. This is 8, 8, 8, and 8. And over here we'll go to docdev AOC lib crates AOC 2019 bacon run. Okay, so day 8 is unsolved. All right, so the first thing we do is get input. 2019 day, what day are we on? 8. Ooh, one line of, looks like it's only zeros, ones, and twos. We don't, when they say color, it's really just 3 different colors. Okay. That's fine. Maybe it's like red, green, blue or something. Okay, so let's parse the input. Let lines equals AOC lib read lines. Input 2019-08.text. It's only one line. So what we can do is, oh, right. So it's going to be at layers of 25 by 6. So right now we don't really need to care about that. All we need are the entries. And it's just a vec of chars. I think that's all we need to do, image data. So we can say let image, self image data is equal to line 0 dot chars dot collect vec. I might have to copy it. No, it seems to be okay. We can print that out. Println self image data and see that we have everything. We don't. What happened? Oh, okay. So bacon just failed on the output because it was too wide. Got it. That was just bacon being bacon. It is a lot of data. Okay, so we have all these data, all these all these entries. Let's not print them out anymore. We can do a bacon run here. So all we need to do now is chunk them up into 25 by 6s and count up the zeros and figure out which layer has the most zeros, fewest zeros. So what we'll do is we'll say self image data chunks of 25 by 6. Oh, I might have to say, as slice. No? Okay, so there's 100 layers. It shows us that. For each chunk now, we're going to say map chunk. And our chunk is oh, it says unknown. It should be a vec of, or a slice of char. So all we need to do is return the count for each chunk.iter .fold. Let's do this way, 0, 0, 0. And we take the fold counts ch, right? And we can then say map, match ch 0 counts 0 plus equals 1. 1. Actually, we don't even have to do that. What we can do is just turn it into an index. Ch as u8 minus b0 as usize. Oh, I have too many dots. Oh, that's why it was probably not working right. Oh, this needs to be in braces. Still doesn't like something. Oh, I forgot a dot here. There we go. Illegal character. Oh, that's right. That's right. I forgot the way folds work. Can I just do it that way? CH is U8 this way? It has to be mutable. Oh, yeah, that's no good. I mean, we don't want to count it anymore. Now what we want to do is take the minimum of I think it's called min by. It's unknown. Yeah, can we fold that way? Or do we have to do it? Spoof says the fold looks good. Okay, well, let's see, min by count of 0. And then maybe we can debug that out and see what we get. Closure expected to take 2 arguments, but it takes 1 argument. AB. That's why it wouldn't. Yeah. Okay. So count. Now it's A0 min B of 0. Min by key. Interesting. Let's take a look. Let's look up min by key. Returns an element that gives a minimum value for the specified function. Oh, okay. So we just do it that. Okay, I like that. Count 0. So that should work, right? Yeah. Okay. So apparently there's only 5 zeros on one of the layers. And now we just need to multiply these two values. Let answer equals this. Right? And then we can just say in here, answer of 1 times answer of 2. Oop. Oh, it's an option. Okay, unwrap. We're going to assume it works. 2064. All right, let's see if 2064 is the trick. Hey, that's the right answer. Okay, that was easy. That was pretty easy. It was easier than I thought it would be. Git commit dash AM 2019 day 8 part 1. All right. 19.8. What did I give it the wrong name? Oh, you know what? I know what happened. Git add source, git status, git, let's see, no edit. No. Something like that. There. Git show head. Okay. Okay, it's all here. Good. So 1908. There we go. All right, let's see what part 2 is. Now you're ready to decode the image. The image is rendered by stacking the layers and aligning the pixels at the same positions in each layer. The digits indicate the color of the corresponding pixel. 0 is black, 1 is white, and 2 is transparent. Okay. The layers are rendered with the first layer in the front and the last layer in the back. So if a given position has a transparent pixel in the first and second layers, a black pixel in the third layer, and a white pixel in the fourth layer, the final image would have a black pixel at that position. Okay, because black came after the two transparents. Got it. So we get the first layer first. All right, so I think we just loop through the chunks just like we did last time, but now what we can do is build up an image. And then what was the image? What message is produced after decoding your image? Okay, so this is one of the AOC puzzles where it generates a multiple lines, and this has happened in previous puzzles where it basically just has a bunch of letters. It turns into a bunch of letters that we can render out. And then we have to use eyeballs to examine it. Or we could write our own OCR. I don't think it's going to be hard. What we can do is we do something similar here, where we take the image data, chunk it over the chunks, and then just map it to an output of some kind. And what we can do, maybe this is cheating, or maybe this is just taking the easy way out, but my normal go-to for solving Advent of Code puzzles is using hash maps. We can do something similar here. Image equals hash map new. And then we'll just say self image data chunks 25 times 6. We're going to map each chunk. And then we're going to loop over each one of these things. And what we'll do is we'll create inside the hash map just a bunch of transparent pixels. And then if it's transparent, we'll overwrite it with a non-transparent or whatever. Legendary Marvin says the important thing is to use brute force whenever possible. Everything under 10 hours runtime classifies as possible. Yeah. I try to get the runtime in under a minute personally, but we'll see. So it's 25 by 6. So it's, we can say 0.25 iter. Or is that already an iter map? Row 0.6. Oh no, that's column. 6 is the row and 25 is the column. Map call image. Oh, it's got a mutable insert, and we're going to just put transparent pixels in there. Row call 2. That's not going to work, right? I'm just okay for row in 0.6, for call in 0.25. I'll do that. Do that. Okay. So now that we've successfully put a transparent pixel in every row column, we can just map over or loop over the chunks. Except maybe we just do it simpler. We do a vec of char. Which is going to be equal to vec bang of 2 of 25 times 6. And then we can just calculate the row column. Right, and then just insert it that way. I think this might be simpler. And then we can just say for row in 0.25, nope, 6, for call in 0.25. Now chunk is a slice of char. So we can say if image of row times 25 plus col is equal to 2, then image of row times 25 plus col is equal to chunk of row times 25 plus col. I think now we want to just do for each. Yeah. And then I think that just gives us the answer, right? If it's transparent, then overwrite it with whatever's there, and we don't even care if it's transparent or not. And then we can just print it out here. We could just chunk it up into. We can say let answer equals image chunks of 25 times 6. Oh, chunks of 25 collect vec. Can I do it as a vec string like that? Will Rust let me do that? No. Oh, because it's a slice of char. So I can say map slice to string, maybe? No? How about string from slice? Will that work? No. Oh, Spoof is suggesting we iterate, copy, and collect it that way. Okay. Well, they're already chars. Oh, but if we iter, then it'll be, yeah, slice iter. And if I just say collect here, it's going to be oh no, that worked without the copy. So the vec string was able to handle it. And then we can just put answer here. So we don't actually need this, or this, or this. Yeah, okay. So now what I actually want to do is map. So we have zeros and ones, and it says something, I'm sure. But it would be nice to be able to read it. So I'm going to do dots and hashes. So map ch match ch 1 hash. Oh wait, was one black or it doesn't matter. 0 is dot and everything else is a panic. Dot. I forgot the closing brace here. There. K-A-U-Z-A. That's what that looks like. So let's try that. Hey, that's the right answer. Yay. All right. That was easy enough.